Namaste, welcome back to Sita Pragna channel. You are watching episode 5 of our chapter 1 data engineering. Today, we are diving into one of the coolest and most important topics in big data, which is Apache Spark's application architecture. If you have ever wondered how Spark makes distributed computing look easy, or how your code magically runs across a whole cluster of machines, stick around. By the end of this video, you will have a crystal clear understanding of the core components that make a Spark application tick, and you will see just how Spark takes the pain out of distributed programming. Now, let me show you a diagram. I'm not going to draw it this time, you guys got spared. Let's jump right in, shall we? Let's select this one. Let's take a look at this diagram. This is the heart of a Spark application runtime. There are three main pieces you need to know: driver program, cluster manager, and executors. You can see that here, but let me write here. Let me tone down this a little bit. Let's break these down in plain English, shall we? First, why do we need this architecture? Well, writing distributed software is hard, like really hard. If you ever wrote a MapReduce program, you would know. You have to split up your program, make sure it runs in parallel across different servers, coordinate the communication, and deal with all sorts of headaches like node failures and network hiccups. But here's the beauty of Spark. You don't have to worry about most of that. You just write your logic, and Spark handles the hard stuff behind the scenes. Now let's talk about the driver program, and I call it the brains of our application. Application is nothing but the script you write. Let's start with the driver program because it's the brain. You can think of this as the brain of your Spark application. It's what you launch when you run your Spark code. I mean, launch in the sense behind the scenes, it up happens. You don't go and launch a driver. Inside the driver is something called Spark context. You might have heard about Spark context all the time. You will see it in almost every Spark script. But what does the Spark context do? Well, it does resource management. What does that mean? Well, it asks the cluster manager for resources to run your job. Think of it as booking seats for your code on the cluster. And who asks that? Spark context asks the cluster manager. Then you have, I don't know why I'm writing cross. Okay, let me try to write like this. State management. What does that mean? It keeps track of jobs are running, what jobs are running, which are done, and helps recover from failures. That's stage management. Then it helps with configuration. It loads your application settings and it can tweak them on the fly. And finally, job scheduling. It splits your logic into jobs, stages, tasks, then schedules them to run across the cluster. What are jobs, tasks, and stages? We'll talk about them. But it does all these things. It is very important. Even in interviews, they ask it because this is core. These days, any GPT can write you the code. But in the interviews, you would have to answer those questions, not GPT. So learn it. Resource management, state management, configuration, job schedule. So whenever you run a Spark job, the driver is orchestrating everything for you behind the scenes, making sure each piece lands in the right place. That's our brains. Then the cluster manager. You can see it in the middle of the diagram, right? Think of this like a traffic cop or an air traffic controller. Its job is to manage all the resources in the cluster, keep track of who's using what, and assign new jobs to the right machines. Here's something cool. Spark can work with different cluster managers. Spark has its own, but it can also work with other cluster managers. And what are those? Spark has one built in which is called, let me go here. S- Spark built in which is Spark standalone. Okay. And then you have from Hadoop, you have Yarn. It's called, I guess, yet another resource negotiator or something. And then you have something called Mesos. This is for generic clusters. And finally, you have Kubernetes for containerized cloud native workloads. But Spark can work with all of this. No matter which one you use, the basic role is the same. Assign resources and keep the cluster healthy. That's what the cluster managers does. And finally, the executors. These are, if driver is the brain, executor is the muscle. On the right side, you can see that the executor is running inside each worker node. This is where your data is actually processed. The driver program sends out tasks. You can see this one arrow. Sends out tasks. You can see tasks in here. And the executors do the heavy lifting. Reading data, crunching numbers, caching results, and writing output. And here's what's great. Executors are disposable. What does that mean? If one executor node fails, the cluster manager and the driver, they work together to reassign the work this was doing to another worker node. That's why Spark jobs can be so fault tolerant, even on unreliable cloud resources. Do you want to save money? Some companies even run their executors on, guess what? Spot instances. If you don't know what spot instances are, these are cheap, preemptible cloud VMs. What is that? I don't even know spot instance, and you are saying preemptible cloud VMs. Well, what it means is any cloud, for example, let's take AWS as the example, it has EC2 machines, right? Whenever you create a EC2 machine, do you think behind the scenes it's just spinning up a server for you? Of course not. They already have a big server running, and whenever you spin up EC2s, they will be like virtual images or VMwares on your computer. So the server is running non-stop. Whether you spin an EC2 on it or not is secondary. Server will be running 24/7. Now you might be asking, if the server can have, let's assume that 4 GB once 10 and only one is it, isn't it wasting the resources on that server? Well, technically yes and no. Because whatever was available, AWS don't waste it. Instead, it puts it in a auction. Okay? It puts it in an auction where you and I can bid on it. Okay? And since it's unused compute space put into auction by AWS, this is going to be way cheaper. It is going to be 90% cheaper than you spinning up an EC2 machine on demand. It's 90% cheap. But the problem is when AWS wants its compute back, it will take it from you. Even if you are running some application, I mean, it will give you few minutes depending on your settings and whatnot, but it will take it back. So that's what I said when I said it means preemptible cloud VMs. So they will take it back whenever they need it, but when they have spare compute power, they will give it for cheap prices. So these are perfect for Spark because let's assume that you are using a spot instance here and you are running, and then AWS said, I have some people asking for compute power, give my compute power back. Then your worker node will fail because it's no longer available. And then the cluster manager and driver will be like, bro, that that worker node went offline. Now that person was doing these tasks, we need to assign it to somebody, and then it will go back and it will assign it to somebody, some other server that you have on your cluster, right? So spot instances are cheaper and they are preemptible cloud VMs. Now you know what preemptible means. Because Spark can recover from failures automatically, it doesn't matter if you use Spot instances or not. A quick tip though, don't just go for the biggest, more powerful executors. Sometimes a bunch of smaller, cheaper machines will get the job done faster and cheaper than one big box. Remember that. Now, I hope you understood this diagram, this awesome diagram. Now, let's look at a classic way you start a Spark application in Python. And this is going to be code, showing code for now because we don't have cluster set up yet or Spark installed yet. Correct? Yeah. Oh my. Okay, let's lower this down. Okay. So I'm going to type this. Now you are going to have something like PySpark dot SQL import Spark session. Okay. Then you are going to create a Spark session. I'll just say first app, and then you will say I want to show this in a single line like this. I mean, you can have it multiple lines, then you need to put a backslash and whatnot. So it's okay. Okay, you got that. So this is your import, and this line is what creates a Spark session. We'll talk about what that means. And then that's about it. Then if you want to stop your Spark session, you can use its spark dot stop. That's it. Now let's look at what is happening here, right? We create a Spark session which under the hood creates our Spark context. Now remember the Spark context? This is what creates it under the hood. Spark session. When you create Spark session, it creates Spark context, which is the driver's control center. Now we can then use the Spark to read our data, process it, and write results. When we are done, we call Spark stop to release resources. Every time you run a Spark app, this structure is being orchestrated behind the scenes. What is that structure? Driver program, cluster manager, executors, and the whole show. So let's wrap whatever we learned so far, not the video, just whatever we learned. There are three core components of Spark application. Spark application. What are they? Close your eyes and repeat it after me. Driver program, which coordinates everything. Cluster manager, which assigns resources and keeps the cluster running. And finally, executors, which who do the actual work processing your data. So thanks to this architecture, you get all the power of distributed computing with none of the headaches as you keep learning Spark. Keep this mental model in mind. It will help everything else make sense. Okay. Now let's cover these things in more detail. Okay. Let's dive into the world of Spark um, ecosystem. We learned about how Spark works behind the scenes, why it is fast, and all that. Now let's talk about Spark's ecosystem. Let's explore its core components, see how it handles both batch and streaming data, and even touch on real world use cases and how it all comes together. Are you ready to level up your data engineering knowledge? Uh, I hope I am hearing yes, not no. Let's jump right in, shall we? First, let's understand the big picture. I just said ecosystem. What is this? Is this an ecosystem like the one we live in, our environment, surroundings, etc.? Well, kind of, but we're talking about Spark here. If you haven't seen this diagram, then I don't know what you are preparing for, because you would have to see this diagram if you are learning Spark. So this is basically Spark ecosystem. This is ecosystem just means it's like a toolbox for data engineers and data scientists. At its heart, you have the Spark core. Okay. Think of this as the engine that powers everything else. On top of this engine, there are four major libraries. What are those? Spark SQL, data frames, data sets. So this is all together for SQL style queries and table like data operations. You will use this, and then you will have another major library for streaming for real-time data processing, and then you have MLlib for running machine learning algorithms at scale, and then you have graph computation for analyzing data that's best represented as graphs. And guess what? We are going to cover all of this. So this we are going to cover in beginner playlist, this in intermediate playlist, and this in advanced playlist. All of this can be accessed using several programming languages, and that you can see Scala. We will cover our hands-on classwork and homeworks in we have I'm not going to stick to just one language. I think in one of the video I mentioned that, and I will say it again. I don't want you to stick to one language. If you haven't watched the introduction video, go watch it. I mentioned how I want you to take advantage of this course and how I want you to skill up using this course. I want you to learn all of this, and it's not that hard. Spark code in one language is very similar to other language, and to make you all learn all these languages, I am going to show you examples in all languages. If you have watched other YouTube videos, they would have stick to maybe most likely Python, but I am not going to stick to one language. I will explain different examples in all the languages. Got it? And don't get scared, and I want you to learn all the languages. Like, not 100%. These days we all use GPT to code. Okay. Again, as I will tell you, you don't have to know the syntax. All you need to know is the concept. That is very important. Got it? So, because job companies are don't think like you. Like, oh, most people are comfortable with PySpark. Let's only write code in Spark. No. If you go and look for jobs, one company will ask for Scala, one company will ask for Java, one company will ask for Spark SQL, one company R. So what are you going to do? You are like, oh, I don't know Scala, I won't apply. No, you are going to lose that opportunity. And it's not even that hard, that much difference between Scala and Python. All you need to know is basic things like how to run your app and how to compile it, etc., which is something that I'm going to teach. So I want you to learn it. Don't skip it. Now, yeah, I don't want you to pick what you are most comfortable with at all. If you're comfortable with Python, that's fine. Be comfortable with it. Explore Scala or SQL as well. It's not that hard. I will make you, by the end of this course, trust me, you will be proficient in writing Spark code in all these languages. Trust me. Leave that to me. Just what I want you to do is listen to me and do what I tell you to do. That's it. Follow me. You will learn all this, and you won't miss any job opportunity that says they want Spark. Doesn't matter which language. And I'm going to cover glue jobs. I'm going to cover Databricks. So any job that puts Spark in it, you should apply it after finishing the masterclass. That's my goal. Now, these are Spark's powerful APIs, right? Spark makes life easier for developers by supporting multiple APIs. Whether you love Python, Java, Scala, R, or just want to use SQL, Spark's got you covered. For example, with Spark SQL, you can write queries just like you would in a regular database. Now let's talk about something super important, which is data frames. If RDD is our big brother, then data frames is like our next big brother. Okay. This is Spark's main way to represent structured data. If you have ever used a table in Excel or relational database, this will look familiar. Let me show you how a regular database table looks like. This is how a database table looks like. And guess what? How a data frame looks like. In Spark, data frames look like this. Do you see any difference between these two? Maybe the graphics is not that awesome, but there is no difference. It's still the same. So that's what I'm saying. Tables or structured data in Spark are represented like a table in your database. Data frames are special because they can be distributed across many machines, letting you process massive data sets efficiently. The data frames came from actually R language. You will also see data sets mentioned, right? If I go up to this diagram, you saw data frames, data sets. We'll cover about data sets in depth in intermediate playlist, just like RDDs. Uh, but these data sets offer compile time type safety. I will explain in detail later on. You don't want to know that in the beginner level. I don't want you to confuse much about RDD's data sets here. Let's learn about data frames. Um, and by the way, data sets are available only in Scala and Java, whereas data frames are available in everything. Moving on, that's this. Next is streaming. What if you want to process data as it arrives instead of after the fact? That's where structured streaming comes in. Spark structured streaming lets you handle real-time data streams with fault tolerance and super low latency. It works almost like batch processing but handles data as it comes in, updating results incrementally. And there is a mode called continuous processing in Spark that can get latency as low as 1 millisecond. 1 millisecond, right? In a second, you have 1,000 milliseconds, if I'm right. That's perfect for things like fraud detection, real-time dashboards, or IoT monitoring, right? Fraud detection, millisecond makes a difference. Um, in streaming, you might run into terms like at least at least once delivery. You will hear this a lot in streaming, meaning the messages may be delivered more than once. At least once means once or more, but never zero, but never lost. How does that look like? Let me show you that here. Remember, does this seem familiar to you? Of course it does. During Kafka, we spoke about it, right? You have a producer, you have a consumer, then you have your messaging queue. So, producer, it might have duplicates. Then you will put records. These are like, let's say in topic, you put these messages, right? All these are different messages. It might have duplicates and the consumer consumes it. But at least once delivery means they are never lost. These messages are never lost. Now, next, we have machine learning. Spark's ML lib provides tons of tools: classification, regression, clustering, collaborative filtering, like Netflix recommendations, and even advanced models like random forest and gradient boost trees. If these words sound foreign to you, that's fine, because that's why I'm covering them in the advanced. And we actually have a playlist on our channel right now which talks about basics of machine learning, and most of these are covered in there. Classification is covered, regression is covered, clustering is covered, random forest is covered. So go check that playlist out if you're interested. Feature engineering tools like TD-IDF, Word2Vec, and more. I think some of these we covered in that playlist as well. Tools for building and tuning machine learning pipelines, exporting models, and calculating statistics. These are all involved or included in the MLlib. The modern Spark MLlib uses data frame based APIs for ease of use and speed. Finally, we have Spark Graph X. If you are working with network data, think social networks or web graphs. GraphX brings graph computations and analytics to Spark. So you can run algorithms like PageRank at scale. Now, do you want to know another cool thing about Spark? Yes, I hear yes. Okay. It connects to almost everything. What do you mean by connects to almost everything? So here you go. You can read and write to Hadoop HDFS, MySQL, uh, Cassandra, PostgreSQL, MongoDB, Hive, Elasticsearch, Kafka, Redis, Spark, and so many more. That's make that makes it a true Swiss Army knife for data engineering. Now, let's break down two ways to process data. We already know that. What are those? Batch and stream. Let's talk about batch processing a little bit here, shall we? Think of batch processing, how would I put it? The analogy like doing laundry, right? Doing laundry, washing clothes, right? You wait for a lot of dirty clothes. Do you wash them every day? Of course not. Nobody washes them every day. You wait for a lot of dirty clothes. Then you will wash them all at once. Similarly, with batch jobs, data is collected over time, usually the entire day, temporarily stored, then they are processed together, often overnight or at set intervals. Spark runs a job to process all the data at night. I mean, usually at night, it can be any time depending on the company and data. Then it writes results to storage and generates reports, which you can see them here. You have the incoming event, then you will do a temporary storage, then you will read cyclic query like during a scheduled time, then you will write it to your target. Okay. Hmm. I thought, okay. Then you have the stream processing. Now, this is if this is like doing laundry, this is like a conveyor belt in a factory. Data flows in continuously and gets processed on the spot, no waiting. Spark ingests data, updates storage and dashboards live, and lets you react to events in real time. Batch is great for historical reporting like monthly payroll or daily sales. Streaming is perfect for live analytics like fraud detection, etc., like credit card, right? Or monitoring IoT sensors. So that's about these two. This is how you process your data. These are the only two types. Okay. Now we are talking about Spark, Hadoop, which are basically big data tools. And I said big data so many times, but you have data. What makes it big? Is it just the volume? Of course not. To call your data as big data, you need to check if these parameters apply or features apply to your data. What are those? Volume. We call them three V's. Actually, there are more V's than three, but basically three V's. It started with three V's: volume, velocity, and variety. If your data, if you have tons of data more than ever before, that's the volume, one tick mark. Does your data arrive fast in real time? That's the velocity. Do you have lots of different formats like tables, images, text, video? If you tick all these three, then you can call your data as big data. And guess what? Spark is built to handle all these three. Now let's wrap the main section by clarifying the differences between data, analytics, and insights. Data, just raw facts and numbers. Analytics, the process of analyzing and organizing this particular data. As you can see, this is like raw data all over the place. Then this is organized. Insights is the aha moment, like, aha, yeah. And patterns you discover that can actually drive business decisions. And Spark helps you move smoothly from raw data to actionable insights, no matter the scale. All right, let's recap what we learned today. Apache Spark is powerful, flexible data processing engine with a rich ecosystem, and it supports both batch and streaming data with libraries for SQL, machine learning, and graph processing. Spark can connect to pretty much any data source, making it a one-stop solution for data engineers and scientists. Whether you are handling yesterday's reports or analyzing live sensor data, Spark has a workflow for you. And most importantly, Spark makes it easy to go from raw data to analysis to real actionable insights. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more practical data engineering guides. And if you want to try Spark yourself in the next chapter, not the next video, we are going to have one more video, and after that we'll go switch to chapter 2, where we can download, install, and play with some sample data. Trust me, you will be surprised at how quickly you can get started. So that being said, don't forget to do your quiz as well as interview questions, and see you in the next video. Peace out. Love you all.